You know, it's funny, we're totally obsessed with physical packaging waste, right? The plastic in our oceans, the mountain of cardboard in landfills, the recycling rates of the bottles we use every single day. But we almost always ignore the invisible, airborne byproduct created during the actual manufacturing of those materials. The simple truth is, the air we breathe is heavily impacted by the creation of the very containers that hold our food, our drinks, and our household goods.
Okay, let's dive right into this. Welcome to The Explainer. Today, we're taking a magnifying glass to an invisible problem by unpacking the Sustainability Accounting Standards Board, or SASB, standard for the containers and packaging industry. We are going to look specifically at how this industry tracks industrial air quality, focusing on metric RTCP 120A1, which dictates exactly how facilities measure and report atmospheric pollutants. It's a really fascinating look into where environmental stewardship directly meets corporate accountability.
Here's our game plan for today. We'll start with the air quality challenge, move into the suspect lineup, check out the interrogation methods, and finally deliver the business verdict. Part 1. The air quality challenge. Converting raw materials into finished packaging requires an absolute ton of energy, which means releasing a significant amount of air emissions. And this brilliantly illustrates our focus for today, SASB metric RTCP 120A.1. This is essentially the regulatory case file demanding accountability for these airborne emissions. It requires companies to lay it all bare and disclose their direct air emissions from everything, from stationary production plants right down to their movable transportation fleets. And as the standard lays out, the whole shebang has to be quantified and reported in metric tons. Moving on to Part 2, the suspect lineup. The standard specifically mandates the measurement of 4 distinct pollutant categories. Let's meet our culprits. Suspect number 1 is NOx, or oxides of nitrogen. Now, the standard is super strict here. When a facility reports its NOx emissions, it absolutely must include NO, nitric oxide, and NO2, nitrogen dioxide. But it explicitly excludes N2O, nitrous oxide. Why? Well, because nitrous oxide is actually tracked separately under Scope 1 greenhouse gas emissions. They want to make sure there's absolutely zero double counting between general air pollutants and global warming contributors. Next up, culprit number 2, SOx, or oxides of sulfur. Now, the standard says this includes both SO2 and SO3. But SASB actually throws reporting facilities a bone here. The standard explicitly allows an entity to just report all of its oxides of sulfur as total sulfur dioxide, or SO2. It's a really pragmatic, practical way to capture the sheer scale of sulfur emissions, which are mostly generated from burning those fossil fuels we talked about earlier. All right, suspect number 3, VOCs, or volatile organic compounds. This one gets pretty technical. It's defined as carbon compounds that participate in atmospheric photochemical reactions. But just like with NOx, the exclusions are key. It explicitly leaves out carbon monoxide, carbon dioxide, carbonic acid, metallic carbides, and crucially, methane. Methane is already covered elsewhere as a greenhouse gas, so we are laser-focused strictly on non-methane volatile organic compounds here. Now, what's really interesting about this is how the standard handles the messy reality of global manufacturing. Packaging companies operate all over the map, right? Dealing with a million different local laws. So, if a local regulatory definition of VOCs conflicts with the SASB baseline we just covered, the facility is actually permitted to use their local legal definition instead. They just have to clearly flag where that definition came from. It's a pretty great example of how the standard adapts to real-world legal frameworks. And our final suspect in the lineup is PM10. We're talking about airborne particulate matter with an aerodynamic diameter of 10 micrometers or less. To put that into perspective, that is literally a fraction of the width of a single human hair. SASB lets entities report this simply as total filtrable particulate matter. These are those microscopic filtrable particles from the manufacturing floor that you can easily breathe in, making them a massive priority for public health and air quality control. Which brings us to Part 3, the interrogation methods. How in the world do these facilities actually catch and quantify these totally invisible gases and microscopic particles? Let's see how this builds. There are 3 approved heavy-duty methodologies used to track these emissions accurately. First, we have CEMES, Continuous Emissions Monitoring Systems. This is where they literally stick sensors directly into the exhaust stacks for real-time data. Second, engineering calculations. This relies on established mathematical models based on equipment specs and operating hours. And third, mass balance calculations. That's foundational science. Whatever materials enter a process, minus whatever stays in the final product, gives you exactly what must have been emitted into the air. Companies just detail which of these methods they use to get their final metric ton count. Finally, Part 4, the business verdict. Why does this highly technical data actually matter to the bottom line? So the crucial point is this: ignoring these emissions is a fast track to steep regulatory costs, heavy non-compliance penalties, and sudden massive capital expenditures to retrofit old equipment. Nobody wants that. But on the flip side, companies that get ahead of this with technological process improvements, they see serious financial rewards. We're talking improved operating efficiency, heavily mitigated regulatory risk, and a huge boost to brand value in a market that definitely scrutinizes environmental stewardship.
So I'll leave you with this final thought. The next time you're holding a beautifully manufactured container, think about the invisible data tied to it. Tracking NOx, SOx, VOCs, and PM10. It's not just some niche environmental science project. It is a critical, real-time indicator of a company's operational health and financial resilience. So ask yourself, is the facility behind the packaging you rely on or invest in truly breathing easy? Thanks for joining me for this explainer, and remember to keep questioning what you can't see.